Hi, this is a video for COMP345, week number 2. In this video, I'm going to present the handout for assignment number 1. So here's the handout. You can find it, of course, on the Moodle page as well as the on my own web page. So let's make this bigger a little bit. So first, this is a team project. So you must form a team by the end of week number 2. So starting on September 18, I'm going to form teams. If you don't already have a team, you will be put into a team. These are teams of exactly 5 members. So there are, as you will see, there are 5 parts to this assignment. You can actually assign each different part to a different student to work somehow independently. This will work somehow for assignment number 1, but starting in assignment number 2, it's going to be assumed that all these parts are working together. So starting in assignment number 2, it's not going to be possible to work in isolation anymore. And anyway, I don't suggest that you work in isolation. You will see very quickly that there are somehow dependencies between each of the parts. If you do them independently, you are each going to design code that is not going to work with other people's code. It's going to be much more difficult than to integrate it together to form a single project. So these are not 5 individual assignments. This is a group assignment. Deadline is October 8th. So when I say a deadline is a certain date, it's always midnight at the end of this day. So there will be specific design requirements. They're all going to be the same for all the assignments. Here I'm going to state them. Some of them have proven to not be so clear for some students. So here are some more explanations. First of all data members of user-defined classes must be of pointer type. What do I mean by that? If you, for example, you design your own player class, which you will have to do, then when you have in another class in your design, you have a data member that is of type player in another type, then the player must be a pointer to a player. Okay, so you're not allowed to have, if you define your own classes, you're not allowed to have another class that has a data member of this type that is not a pointer. This is basically to force you to do manual memory allocation, to care about your memory allocation. We will see later that if you have pointers, that essentially forces you to do your own memory allocation, the constructors and destructors. So this is some things that we will see later. All the file names and contents of the files must be according to what is specified below. For example, in part number 1, the map, I say there should be a map class, there should be a map loader class, and for part number 1, there should be 2 files and only 2 files, and they both should have exactly the names map.cpp and map.h. So if you recall from the first videos and the first lecture, in week number 2, I talked about the CPP file and header file. It must be done exactly as I described on the slides and in the video, and as well as in class. This is one of the things that I was explained in class. So for each of the different parts, the map says you should have these 2 files. Player, you should have also player.cpp, player.h. Order list, the same thing. So for each of the parts, you should have 2 files, the CPP file and the .h file for each of the parts. If there are many classes that you will implement, you should not have a file for each class, such as you have in Java. All your classes must be in these 2 files. Okay. I do this because I want people to take the habit of having multiple classes in one file. It's not necessary, but it's one of the things that is different between Java and C++. So you must come to use this feature of C++. See, that's what I'm doing. I'm designing this project so as to force you to exercise some of the features of the language. That's why I have these additional restrictions, design restrictions. Our class must implement a correct copy constructor, assignment operator, and stream insertion operator. So for, as we will see also in week number 2 and follow up, in C++, sometimes you have to implement your copy constructor and assignment operator if you're using pointers. So I'm forcing you to use pointers here, and then I'm forcing you to define your copy constructor and assignment operator. There's also a stream insertion operators that is defined in slide set 3 in input output. Stream insertion operators are defined or explained, so you must have these for each of your classes. Very common problem, prevalent problem in C++ is memory leaks. You must avoid memory leaks. The way to avoid memory leaks is mostly that you define your constructors and destructors and your copy constructors, assignment operators in a way as to avoid memory leaks. Again, this is all explained in the slides and in videos and in class. Your code must be documented. So every of your classes, methods, free functions, and operators must be documented. There must be some comments at the beginning, before the beginning of your code for every class, method, free function, and operator that describes what is the purpose of this piece of code. And this will be part of the grading of the assignment. Last, if you're using libraries, it is possible, actually highly probable that, well, unless you're using STL, it's highly probable that the markers will not have these libraries. So it's possible that during the marking, if they have to compile your code, if they feel they have to compile your code, that you will have to meet with them in addition to the actual presentation of the assignment. It's not necessarily the case, but it's just a warning. If you use external libraries, it may be the fact that the marker will want to meet with you additionally. So here are the 5 parts. First of all, I'm not going to explain all the details here. So again, the expectation is that you listen to this video and realize that there are some things I don't say, come in class and then ask questions. Okay, I want to have discussions so that it represents what's happening in real life as much as possible. So the part 1, the map. So of course here you're playing this game Warzone. So Warzone, as I explained in the project description video, it's implemented using a graph. Now there's different ways you could implement a graph. So for example, you could implement a graph using directly a graph with nodes and edges and so on and so forth. So that's what I want you to do. As opposed to, for example, you could also use an adjacency matrix. You're not allowed to use an adjacency matrix. It should be a graph data structure that you use. If you use an adjacency matrix, you lose the most of your marks for the map. Okay, so you must use a graph that is composed of nodes and edges. So the nodes are territories and the edges represent adjacency between the nodes or the territories. So each territory can have any number of adjacent territories. But if you think ahead, then you'll readily see that your nodes are countries, and then the edges are essentially a list of pointers to other countries inside every country, thus creating a graph. Okay. The map, each territory is owned by a player and contains a certain number of armies. So that means in a territory object, there is a data member player and a data member armies. So now right away you see that you have the notion of player inside of a territory. Now player is another part that potentially another student has to do. So that's where you start having some dependencies between your code. For assignment number 1, the player could be totally implemented separately, but eventually when you will do assignment number 2, you will have to put these things together and add more features, assuming that all these parts are working together properly. So at this point, you can have, for example, if you designed a map, yes, you must have a player inside of the territory, but as the designer of the map part, you can design your own player class, which might be, for example, an empty class, just a dummy class. Later on, assuming that you were going to put the real player class designed by your teammate. Okay. So the map class can be used to represent any map configuration. It should not be representing, for example, the world map. Okay. Your map class should be designed so that it can represent any map, any graph. So the way I will ensure this is that you will also, as you design the map, you will have to design what's called a map loader class that is able to read any map that you will find on this website here. So you will see when you visit this website, you will see there's a list of maps. There are zip files. You download a zip file. Inside the zip file, you will find a .map file, which is a text file that essentially describes a map. So you should be able, the map loader should be able to read any of these files, and then read the file, parse the file essentially, and then create a map as it's reading this file. So you should have a map and a map loader. These are two separate classes that you must have. It should not be the loading of the map inside of the map class. So you see, I'm giving you some design restrictions here. So that, as I explained earlier, I'm trying to force you to exercise some features of the language. That's why I'm giving you these restrictions. And as the markers will give you marks, they will make sure that you abide with these restrictions. If you don't, you will lose marks. So the map loader should be able to read any text file, not only these .map file. If you make the reader read a file that is not a valid map file, it should not crash. It just basically say this map is not the correct format. So it should be able to read any text file and reject them that are those files that are not a valid file. So here I'm specifying, you have a paragraph like this for every of the different parts. So that's specifying that in order to implement this, you must have only two files, map.cpp, map.h. They must be used in exactly the same way as I described in class. Okay, so your H files, your header files should contain the class declarations, and then the CPP, the corresponding CPP file should contain only the method definitions and free functions or operators if you have some. Okay. So make sure that you abide with what I described in the slides and in the videos and in class. In addition to this, for the purpose of testing this, this assignment, you must have, for part number 1, you must have a map driver.cpp file that contains a main function that essentially exercises this code and then shows that it actually has the features as described in the assignment. For each of the different parts, you need to provide such a driver file, a separate driver file that exercises this part. Okay. There are different ways you can organize this. Some people might want to have for the entire assignment, basically have only one main function that in turn exercises each of the different parts. So in this case, you would have a single file that will contain, of course, one main function that would be calling each a different free function to exercise each of the different parts. Okay, so there are different ways to do this, but the essence is that you must have a driver that exercises the code as I described in the assignment. So always also for each different part, I'm explaining more specifically what this driver should do. In this case, this driver should show that you can successfully create a map by reading a set of domination map files and successfully create a map for the valid map files and reject map files that are not of the correct format. After a map object has been created, driver should demonstrate that the map class implements the following verification. First, the map is a connected graph, the continents are connected subgraphs, and each country belongs to one and only one continent. You should have some code in your main function that somehow proves that these conditions are true. So what I have here in the tables here, essentially a point form list of things that I've stated in the above description here, so that you have a clear description of what is necessary to provide for this part. So it's basically repeating what I said before, sometimes in other words, but it's essentially giving more details in point form about what needs to be done. So part two, the player. So you have a class, you have a player. As we saw in the map, there was also mentioning a player. So here is the implementation of the player itself. So what is a player? Here you will see that the player actually connects many of the different parts together. Okay, for example, a player owns a collection of territories. So that you need to have a territory class inside of part number one, because each of the nodes are territories. Then the player itself will contain a list of territories that it owns. So it should be a list of pointers to territories that are on the map. Player owns a hand of cards. So you will see part number 5 is implementation of the cards. So there must be a hand of cards as described in part number 5 inside of the player object. Player has their own list of orders to be created and executed in the current turn, which is to be implemented in part 3. So you see that the player actually contains many of the things that are required for the other assignments, for the other parts. A player must implement following methods. So you see here, well, here also I was mentioning some methods that need to be implemented. So I'm giving you some design restrictions. If I'm telling you there must be a method with this name that does X, you must have this method. The markers will be looking for this method and looking that it does the right thing. If you don't have this method, or you have a method of a different name, or you implemented the same thing but in a different way, you will lose marks. All these methods that I'm asking you to implement, eventually many of them are going to be referred to in the following assignments, assuming that they are there. If you don't have them, you will have to redesign your code so that they will be there for the next assignments. So might as well do them correctly now. So the player must implement a method named toDefend. So eventually the player is going to have to decide which of their own countries they would prefer to defend. For example, put more armies in some of the territories that they feel that are more important for them. Okay, so you must have, at this point, you must have a method named to defend. It should not decide in an intelligent manner which of their countries is to defend, but to defend should return a list of territories. As for now, basically return a list of arbitrary territories that they control. Same thing for a method to attack. So a player eventually will want to conquer other territories that is not theirs. So then the to attack method, what it does is returns a list of territories that the player would like to conquer. So at this point, you should need only to have a method to attack that returns a arbitrary list of territories. Another thing that a player will do eventually is to create orders. So you must have a method named issue order that creates an order objects, essentially, creates an order objects and then puts it into its own list of orders. So as explained earlier, the player must have its own list of orders, and then issue order, when you call issue order on a player, it internally creates an order and then puts it in its own list of orders. Again, the files here, I'm specifying that whatever code that you need to do this is if there are many classes, they all should be into player.cpp and player.h. Then you must have a driver named player_driver.cpp that has a main function that exercises the code to essentially demonstrate that the player class has a to defend, to attack, issue order, and so on and so forth. So you may see that readily there are some parts that are more involved than others. For example, the map is much more code, at least at this point in time, compared to the player. So a player is essentially some kind of empty shell of what will be a player later. However, the map needs to be the real map, like from the start. Okay, so the map, arguably the map, not arguably, but literally the map, if a student does the map part, they will have more work to do than the player part. Okay, so it's up to you to figure out how to separate the work evenly in your team, or at least knowingly. If somebody wants to do the map part, they should know that they will have more work to do than the student that does the player part. Such also is for the order list. It's one of those that is a smaller part. So here you see in the player, I have explained how a player has a list of orders. So here, essentially part 3 is to design this order list. Right away, here you see this is a list. So yes, you are allowed to use STL containers to use, for example, the list class or array list or whatever that you used to have, which behaves like an array list that you had in Java. So you will see in week number 2, there are some slides that describe or briefly describes STL containers. If you don't already know them, you should look at what is available. And you, of course, yes, you can use STL containers to implement your orders list. So the orders list is essentially a list of order objects. As explained in the project description video, there's different kinds of orders. Some orders are played by cards. So what you must have here is you must have a superclass named order, and then for each of the different kinds of orders that there can be, and you will have a subclass of order. Okay. Again, this is an additional design restrictions that I impose. It's not necessary. meaning that this is the only way you could implement this, but this is how I am telling you that you must implement it if you want to get all the marks. So you should have a superclass order, and then you should have a subclass for deploy, advance, bomb, blockade, airlift, and negotiate orders, which are subclasses of the order class. All the orders classes must have a validate method that verifies that this particular order is valid, that order of this particular subkind is valid. All the orders must also have an execute method that eventually the game engine will use to execute this order. Okay. As described in the project description, the game engine is what controls the flow of the game. So we'll ask, for example, ask each of the players to create orders, put them in their order list. Once the players have all finished issuing orders, the game engine will ask each player in turn to give them their next order and execute the order by calling the execute method of the order after they got the order from the player. So note that the order's actions don't need to be implemented at this point. Okay, many of the things I'm asking you to do here are empty shells that are there just basically to implement the structure of eventually what you will have to do. For example, you don't need to implement the code for the validation or implement the code for the execution of the orders. Okay. There are many things that are not in place yet that would not allow you to actually do it anyway. So what I'm saying is that there should be order objects. They should have a validate method and an execute method. One thing I didn't say yet is that for the list, order list, which should be an object in itself, this object should have a move method and a remove method so that the player can actually move the orders in their own list or remove some of the orders in their own list. All this must be implemented in orders.cpp and orders.h file. And then you should have a CPP file that contains a main function named, the CPP file is not named orders_driver.cpp, and it should exercise the code in a way that I described here. Fourth part is the cards and the deck and the hand of cards. So in the game, that there's a deck of cards. So sometimes you are given cards in the operation of the game. As you conquer some territories, you will eventually be given a card. So you get the card from the card deck. So that's one of the things that you must implement here. So of course, then a card is a, for example, a list of cards. It's a container of cards, and the players will pick a card from this deck of cards. And then each player will have their own hand of cards, which is also a container of cards. So you must implement the card deck and the card hand. Each of them must be two different classes. You see, anytime I present something in bold like this, this actually says you must have a class of this with this name. And this class must have a method with this name. Anything that is in bold specifies that this is something you must have of this very specific name. So it's pretty simple. So you create a card. So for each of the cards, as described in the project description document and video, it says what are the different cards, different kinds of cards. So for each different kind, you must have a subclass of the class card. And then your deck is a collection of objects of type card, and each of them are a subclass of card, depending on what kind of card they are. Same thing for your hand of cards that the player will hold. So the deck must have a draw method that the player would call to actually draw a card from the deck. Then every card must have a play method that the player will call to actually play the card, thus implementing the effect of the card. After the card has been played, the last thing that the card will do as you play the card is to actually put back the card into the deck. So you see this one is pretty simple. This must all be implemented in cards.cpp and cards.h. You must have a driver that exercises the card, the hand and the deck of cards as explained here. Last but not least, which is also putting everything together, is the game eventually will be putting everything together is the game engine. Here I present it in a very isolated way. Okay, basically here I'm asking you to implement the game engine as some kind of state transition diagram. Okay, the state transition diagram is presented here. So essentially, what you must implement as the game engine is has a state that is a variable that is maintained by this game engine class, and then how do you make transitions between states? By having the player to type commands on the console. So you start, for example, start, of course, is the starting state of the whole game. So first you start by putting the game engine in the start state. Then the game engine waits for the player to enter commands. The only command at this point that can achieve something useful is load map. So the player should type load map. Here, you're not really loading a map. So essentially, when you implement this, the only thing you do is you have an object that has a state and then waits for the player to type something on the command line. If that's something, if you're in the start state, and the player types load map and press enter, then you change the state and go to map loaded. Then at this point, if the player types load map again, then you stay in map loaded. If the player enters validate map, press enter, then you go to this map validated state. If the player then types add player, then you go to this other state here, and so on and so forth. Okay, so eventually these strings that the user enters now, they will actually be commands that will have an effect on the objects in the game. Of course, for example, when you're in start state, eventually when the user types load map, they will have to specify what is the name of the file that they want to load. At this point in time, they just basically say load map, and then you go to the next state. Eventually, not now, users will have to specify what are the parameters to each of these commands. But at this point in time, the only thing I want you to do is to implement the state transition mechanism portion of the game engine. Okay. So here there's the notion of state, the notion of transition, and the notion of command. So every state essentially is a state of the game engine. The transitions are essentially commands, are triggered by commands that the user will enter. The other thing that it must do also is that it should reject the commands that are not applicable to the current state. So for example, if the game engine is in the start state and then the user types win, then it should not accept this command. It should say this command is invalid in the start state. Okay, so you should only accept valid commands for this current state and reject and tell the user that this command was invalid for this state for every of the different states and combination of commands. And then you go here, it's pretty simple what kind of driver that you should have. So you start this whole thing and starts in the start state, ask the user to enter new commands, and then it should basically allow the user to navigate this this DFA by typing commands on the command line, typing strings on the command line as specified here. So that's about it for a description of assignment number 1. So please start as early as possible. Start discussing with your teammates as early as possible. Come in class prepared with some questions that there are many questions, as I'm sure you realize by now. There are many questions you can ask about this assignment. I'm going to expect every class that you come prepared and that you ask questions toward the end of the lecture time. So that's it for me for this video. Thank you.